Hi, I'm Ameya Chaudhary. I'm at University of North Carolina, Chapel Hill. I'm a PhD candidate in Juliane Nguyen's lab, and I have received the PhRMA Foundation Predoctoral Fellowship in drug delivery. My grandfather was actually a professor of pharmaceutics back home in India. He often would bring home reagents from his lab, and we would make soaps, shampoos, and creams together, which is really fun. And he would often talk about his stories, his research, and mentoring students, and that really sparked my curiosity. I would often help him troubleshoot experiments and pitch ideas to him, even though back then my ideas were pretty naive and they probably didn't end up being anything, but he was super encouraging about it. And I think that's really what sparked my curiosity. In Dr. Nguyen's lab, I work on developing auxetic elastic sticky patches. We are developing these as skin meshes that adhere and flex with skin without sutures. That imagine having an elastic band and imagine stretching it. If you were to stretch it, you would experience contraction in the center. Those are non-auxetic structures, whereas our patches, they have geometries that actually allow them to be stretched without the contraction in the center. That allows them to stick better and expand better and stay on the site of action longer. You could essentially put these patches onto a punctured lung and block off the air leakage. And then the patch can stay on as even if the lung expands and contracts, the patch would do that, as opposed to, a patch that was not auxetic that would undergo some fatigue over time and actually detach. They're bioadhesive and drug loadable. So you can load various drugs in them and use them for various applications. One of the drugs that we are loading, these are known to promote wound healing and regeneration. And they're also biodegradable, so you don't need to take them off. We believe that this innovative approach could help in faster and more effective healing of diabetic wounds and improve patient outcomes. I think this fellowship really empowers me to explore innovative drug delivery technologies and gives me the confidence to pursue my own research. And I think it is really important for younger scientists to have this kind of feedback and have this kind of support, which would really allow them to be more confident in pursuing their own ideas and research. Research is hard and failure is very common. You would go through a ton of failure, a ton of failed experiments. However, after the 99 failed attempts, the 100th attempt is absolutely euphoric, and it's definitely worth every second and effort you've spent. All the failed experiments and all the time we spent waiting for experiments to get completed, we would essentially spend a lot of time playing ping pong. And I have gotten really, really, really good at ping pong over the 4 years that I've spent doing my research. So there's something that comes out of, even I guess failed experiments. I would take all my anger out on the ball. So the most fulfilling aspect of my grad school journey so far has been being able to collaborate with passionate scientists at UNC. Our lab and my research is more so on the engineering side, and it's really important to have clinical collaborators who actually know what's going on in the clinic and help us guide our engineering efforts to improve patient health. I would like to work in industry for a few years to gain some experience and understanding how to translate technology from the bench to the clinic. And then few years down the road, I would like to start my own biotech company with the hopes to sort of bringing a hypothetical idea all the way to clinical translation. I think that would be my dream. Even maybe advancing these exotic patch skin or skin mesh technology all the way up to the clinic and allow for better patient outcomes.